Hi, I'm going to discuss about two-input NAND gate designing using 10R in Mentor graphics. So, NAND gate is having two inputs and one output. If while giving the 0 0 input, 0 into 0, 0 bar means 1. Like that 1 into 1, 1 bar means 0. So, if the inputs are multiplication, that is NMOS transistor should be series and PMOS should be parallel. Then only we can get the outputs easily. If it is addition, then the NMOS transistors should be parallel. So these are the rules to design any circuit. So then we need to execute our required designing. So for that, we need to go for schematic edit, file, new, new design. I'm giving name, some name, and click on that, add. Here we need to add the library files. One by one I am adding analog libraries, added. Then again I am going to add libraries, input output paths I am adding, added, click on OK. Then again I am adding, go back, logic gates I am adding, click on OK, added. Now we can go for to design cell new view, click on OK. So this is our required schematic view. Here we need to design our design. For that we need to go for generic 250 nanometer devices and select PMOS transistors 2 are required. Click on instance. So this is the PMOS transistor 1, PMOS 2. Click on escape and click on NMOS instance. 2 are required, 1 and 2. So 2 transistors are enough. Then go for ground. For MISC, select MISC, miscellaneous components, and the ground is required. Click on instance. 1 ground. There are 3 more grounds are required. 1, 2, 3. Click on escape and supply is required. Click on VDD instance supply. One more supply required. Click on escape. Then give the connections by using wiring, and here we can go for wire. So a wire option is there. Give the connections from here to here and here to here and here to here. As per circuit we need to give the connections, supply, and this one we need to give the connections, and here it is ground. And then give the input and output ports. This right side corner we have input and output ports, and this is I am assuming A, and this is A, and one more A is required. This is A, this is A. One more A is required because we are giving the input A. That A we have given A completed. Then go for B, input B. Of course this is an output, and output name is same as a out. I am assuming this is B and this is B I am given, and one more B is required, B, and this is B I am assuming B. Click on OK. Now we have given B. And before that, we need to give the power supply and inputs. So for that, go for spice elements, and for that voltage source. And here, this is an input. Click on instance. So this is input B, and this is an input A. Click on escape. And one supply we required, here only it is available. Click on instance. And this is an input voltage. Then again give the connections using wire option, and this is an wire option. Click on that and give the connections. Give the wiring connections properly. So here, from here to here and here to here I have given, and we can give the wiring connections easily anyhow. Just click on that, we'll get easily. Here, from here to ground, here to ground. So now the connections are given. Two more are there. So here, and from here to output. So now the connections are completed, and but to observe the input output waveform, some printer is required. For that, we need to go for spice commands. Click on spice commands here, and that print voltage option is there. Here print voltage option is there. Click on instance, and I'm going with, this is input A I have given, and this is for input B I have given. And to check the output, I have given the output at the output side. Then click on escape. Now everything connections are given. All connections are completed. Then we need to go for setup simulation. And setup simulation, general, go for general. We need to enable this or true, should be true. And then click on transient analysis. And here we need to mention the minimum maximum time, stop time. 1000 nanoseconds I am giving. 1000 nanoseconds, and here I am giving 1 nanoseconds. So these are not fixed, we can give any values. 0 nanoseconds we have given, and remaining same. And but before that, in general we need to add library files here, and go for this library files. 250 nanometer technology, then that generic 250 nanometer library you should add. One more small change here, and add space and add pt here for library files. Then click on transient analysis, already we are given, so then click on OK. Then go for saving, and then we can see this start simulation option is there, that is green button. Then click on that. It will take 30 seconds time to get the input outputs if you are executed properly. The waveforms will get it on waveform edit. This is the input output waveforms. If you want separate, you can click it here on the top side, so we can separate. Now we can see this 1 into 1 1, but the output should be bar means 0. 0 into 0 0, bar means output should be 1. So this is the way to design anything. Thank you. Thanks for watching.